I have the number 2. Is that a power? Huh? All numbers are powers. This actually, if there's no exponent there, what is it? A 1. Exactly. Okay. So all numbers are powers. We just don't put the 1 there because that would just take too much time. It's like almost double work. You have to write a number twice. So every number technically is a power. A power is nothing more than a number raised to an exponent. Okay? The number 2 is the base of the power. The number 1 is going to be our exponent of the power. Now, next semester, when we get into logs, that's going to, you're going to have to know those like the back of your hand. Okay, what does a power mean? If I have a number raised to an exponent, what does that exponent tell us? Yes, ma'am.
1.
Yes. Okay. Depends on the number of the exponent. Like we have 2 to the 5th means I'm going to multiply that number by itself 5 times. Doesn't mean I'm going to take 2 times 5, which a lot of you will do continuously over and over again. It means I'm going to take 2 times 2 times 2 times 2. Now, does everybody know how to put that in their calculators? There's a little caret key for the powers. It's a sergeant stripe. Isn't it called a caret? Yeah, I'm pretty sure it is. Okay, so in your calculators, this is the caret key. This means raised to the power. So I'm going to have 2 to the 5th, so I'm going to have 2. There's my caret key. Raised to the 5th. And that's going to equal 32. Now, algebra 1, you had to multiply it out, right? Teacher wanted to, hey, we want the number 32 there. Algebra 2, we're past that concept. Okay, so if you leave the answer with the number 2 to the 5th, you're not going to get it wrong. Unless the problem calls for a full evaluation or a full solve. Then you're going to have to multiply it out. All right, so let's look at A here, example A. I have x times itself 1, 2, 3 times. So it's going to be x to the 3rd. I have y times itself 1, 2 times. So it's going to be, y squared, right? So x cubed y squared. Now, this problem's easy. When we get into lengthier problems, it might help you guys to put the x's together because this is multiplication. I can change order to commutative. And then I can put the y's together. And like I said, when we get into longer problems, it could help you doing this. I have 3x here, so I have x cubed, 2 y's there, so y squared. Makes it a little easier. All right, B. I have 4x 3 times, right? I have 4x 3 times. Am I good with that? I would have to take a point on the answer. Yes, because this is 4 3 times and x 3 times. And that's a conceptual error. So you go from 5 points to 3 points. And there's nothing I can do about it. It's a conceptual error. You go from an A to a C on that problem. Just because you didn't put the power to the 3 on the 4. Yes. So now there's another way you can write that. You can say, well, I'm taking 4x and I'm going to raise it to the power 3 times. That's correct. Yeah. This is called the power rule. There's a property for this. So either one of these is okay. If you write 4x cubed, that's automatic point off. So be careful. And then we got it multiplied by 3y squared. Now, that's a perfectly acceptable answer. If you're really bored and you want to listen to my math videos rather than watch Netflix, you can sit there and multiply all this stuff out, okay, as someone's doing. So this is actually 3 squared y squared. You can multiply, well, 4 times 3 is 64. And the other number, 3 times squared is 9. And then we have our x cubed, y squared. And then 64 times 9 is 36. Carry the 3, 54, 57. X cubed, y squared. So if you're really bored and you want to multiply it all out, and you're watching my videos, and you're so excited to multiply it out, do that. I highly suggest not doing it because you'll get tired of me. This is a perfectly acceptable answer. Okay? This is a perfectly acceptable answer. That's what I'm looking for. Okay? If you're doing this, you made your Algebra 2 teacher very happy, but I'm not a happy person. Questions, comments, concerns? Okay, let's talk about negative numbers raised to a power. Negative 3 raised to the 4th. If you take your calculators and we do negative 3 to the 4th, I'm going to take negative 3 raised to the 4th. Put an enter, I get negative 81. Most students are going to do this. Well, that's negative 81. Is it though? No. Why? It's positive. Yes. We're taking negative 3 times itself 4 times. If you're using your calculators, you're taking negative 3, put it in parentheses, and you're raising it 4 times. Then you get your positive. You want to know why that happens? Exactly. Your calculators follow PEMDAS to the T. It is so strict. It's saying, well, what it really is negative 1 times 3 raised to the 4th. So it's following PEMDAS. 3 to the 4th is 81 times negative 1. Gives me negative 81. That's why I tell students, when you're dealing with negative numbers, use parentheses. Okay? That way you don't have to figure out, should I use parentheses or shouldn't I use parentheses? Do I have to use parentheses? Whenever you use a negative number, just put in parentheses. Supposedly there's updates on these where I don't know. With fractions, I would do it with fractions too. Get used to putting fractions in parentheses. That way it will never, you avoid the problem, calculate the problem. Okay? Now, on a problem like this, I could catch it on a quiz. That's easy. But if it's embedded somewhere in a problem, you know, when you get down to these, I'm not going to, yeah, chances are I'm not going to catch it. You know, I'm not going to work your problem out and say, oh, here it is. This is the calculator mistake there. If I did that with every problem on every quiz, it'd take me 3-5 days to grade a quiz. I can't do it. I'm not going to always catch it. So be careful with that. And B is just what we did. If I have the -3 without parentheses, it's taken -1 times 3 to the 4th, which this one is going to be -81. Okay? Watch those parentheses. All right. And that's what this next section is. It's working on those PEMDAS rules, order of operations. Huh? Yeah. If you're going to put these in calculators, write it, put it exactly the way it is in a calculator. Okay? I don't give no calculators tests or quizzes, so you're okay if you put this, but don't. Got to put the parentheses where they are. You got to put the minus signs where they are, the negative signs, the exponents exactly the way it is. Otherwise, you're going to get a different answer. Or you could just do it manually. Do it one step at a time. Parentheses first. -4 plus 2, parentheses first, raised to the second power. So, -2 plus 5, 3. Exponents next. -4 plus 2, 3 raised to the second power, 9. Multiplication division next. 2 times 9 is 18. -4 plus 18 is 13. C, right away, they're trying to trick you up again. Left to right, you read left to right. The first thing you do is, 3 plus 4. Oh, I'm going to put 7. Wrong. Multiply first. 4 times 5. 3 plus 20 minus 4. Now I have addition, subtraction. Go left to right. 23 minus 4, 19. Okay, combining like terms. One thing, there's a couple of things to watch out for when you're combining like terms. This 2x plus 4 you cannot combine. Why? Yeah, one's a constant term, one's an algebraic term. Algebraic term has the variable in it. Constant term is just a number. P is a coefficient of the variable. You have to do the multiplication between these before you add 4. You can't do it, so leave it. It's simplified. It's evaluated. Now, like terms, the next example here, I have a 3x and a minus 2x. Okay? You're just doing the operation there. You're subtracting, so you're not going to get an x squared. So I have 3x minus 2x is 1x, or just x, plus 7 plus 8 is 15. And again, in example 1, don't put 3x squared there, or 11x squared is a common mistake. You're not multiplying the x's, you're adding the 7 and the 4, and you're adding x to the first plus x to the first. Not multiplying. It should just be 11x only. When you multiply, that's when you add the exponents. We're not adding exponents here. Number 2, this time we have only combined the n squared. 3n squared minus a 1n squared, 2n squared. This is n to the first. I can't combine it. I leave it. 2 different exponents. Number 3, I have a number out in front of parentheses. Distribute 5 times 2x, 10x, 5 times 3, positive 15. Different terms, leave them. Now, number 4, I am multiplying x's together. So what do I do with their exponents? This is x to the first times x to the first. You add the exponents, right? So I get x to the second. 3x times negative 6 minus 18. Don't forget the x. These are different exponents. Leave it. And B. But all I'm doing here is then take it here. Let me do this another way. So at number 4, I'm taking 3x times 8x, right? That's my distribution product. Okay, so I'm going to multiply, I'm going to regroup these as numbers and x's. So I have 3 times 8, and then x times x. With me? That's how I got my 24x squared. Because there's 2 x's, and there's actually 2 numbers, but I multiply them together. That help you out? All right, number 5. 4x times 5x, 20 squared. Good. 4x times 4. Great. Don't multiply to the minus 18x outside the parentheses. This one does have some that I can combine. I have x to the first terms. So I have 20x squared minus 2x, right? One more. Yeah, I was thinking number 9. Okay, this is 0.5, which means 1/2, right? So 1/2 times 8x, or half of 8 is what? 4x. So I have 6 times 1/2, so half of 6 is 3. Negative 3 times 2x, negative 6x, negative 3 times 4, negative 12. 4x is negative 6x, negative 2x, and then positive 3 minus 12. I think we'll stop here.